Hi students, this is AJ sir. Let's read 10th standard ICSE Math, Quadratic Equations Word Problems Part 2, Exercise 6B. Exercise 6B, Question 2. The hypotenuse of a right angled triangle is 26 centimeters and the sum of the other two sides is 34 centimeters. So let's assume one side to be x. So the other side would be 34 minus x. Now, as per Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So that's how we get the quadratic equation. Open the brackets using the formula a square plus b square minus 2ab. That's the quadratic equation. Divide by 2, splitting the middle term, and we get two values. If one side is 24, the other would be 10 because the sum is 34. And if the first side is 10, the other one would be 24. So the two sides are 24 and 10 respectively. Make sure you mention centimeter. Next, cancel the third sum. Now the fifth one. The diagonal of a rectangle is 60 meters more than the shorter side, that is the breadth. And the larger side, that is the length, is 30 meters more than the shorter side. Find the sides of the rectangle. So let the shorter side, that is the breadth, be x. That means length would be x plus 30 and diagonal would be x plus 60. The diagram looks like this. And we know that each angle of a rectangle is 90 degrees. So we can use Pythagoras theorem here as well. So hypotenuse square is equal to the side squared plus this side squared. So that's how we shall get our quadratic equation. Get the like terms together. Do it on your own. Don't just copy. And then splitting the middle term, we get two values of x. Negative value is rejected obviously. So if the breadth is 90 centimeters, the length will be 120 centimeters. Next, the seventh question. There is a footpath of uniform width running around the inside of a rectangular field. Be careful that here it is inside, not outside. The actual length and breadth are 32 meters and 24 meters respectively, and the path itself occupies 208 meters squared. What is the width of the footpath? So we will assume the width of the footpath to be x. So this is x. Now the actual length is 32 and 24. So what will be the inner length and the inner breadth? You see, if this is 32 minus x from here and minus x from here, so the inner length is 32 minus 2x. Similarly, the inner breadth would be 24 minus 2x. Now, the area of the field is 32 into 24, obviously 768 meters squared. The width is x. So for the inner rectangle, we have a new length and breadth. So the area of the inner rectangle will be the new length into the new breadth. Open the brackets and get a quadratic expression. It's not yet an equation. Now, area of the footpath is the total area, that is the big area, minus the small area. That will give me the area of the footpath. Big rectangle minus small rectangle area. The big rectangle area we know is 768, and the small rectangle area we've already calculated it. When you open the brackets, make sure that the signs change. This minus becomes plus, this plus becomes minus. And the area of the footpath is already given in the question. It's 208. So that's how we get our quadratic equation. Simplify it, solve it to get two values of x. Now, x is equal to 26 is impossible, because how can the width be of 26 when the breadth itself is 24 meters? So that means that only x is equal to 2 will be accepted. Next, mark the ninth sum as IMP. The dimensions of a rectangular field are 50 by 40, and there is a flower bed inside the field, leaving a gravel path. So we'll assume the width of this path to be x meters. The total cost of laying the flower bed that is the inner rectangle, the rate is given, and the total cost of graveling the path, that has a different rate, and rupees 52,000 is the total cost. So first of all, this is the diagram. We have the original length and the breadth. The width is x, so the inner length will be 50 minus 2x and the inner breadth will be 40 minus 2x, which is the flower bed. Now area of the entire field is 50 into 40, which would be 2000 meters squared. And for the inner rectangle, length and breadth is this, so the area would be length into breadth, and the expression we get is 4x squared minus 180x plus 2000. Now area of the gravel path, that is this area, is actually the big rectangle area minus small rectangle area. So that's 2000 minus this expression, and again be careful when opening the brackets, the signs, which comes up to minus 4x squared plus 180x. This is the area of the gravel path. Now the total cost is 52,000. It has two components. One is laying the flower bed and the other is graveling the path. For graveling the path, the rate was 20, and for laying the flower bed, the rate was 30 per meter squared. So we have area into rate plus area into rate. That is area of the gravel path into its rate plus area of the flower bed into its rate. And that total is given as 52,000 rupees. So that's how we got this equation. And then simply open the brackets, rearrange the terms, and you get a quadratic equation. Simplify it, solve it. You'll get two values of x. X is equal to 40 is impossible. The width cannot be so huge because the breadth itself is of 40. So we'll accept the value for the width of the gravel path as 5 meters. So that was an IMP sum. Next, the 12th sum. Even mark the 12th and the 13th sums as IMP. In the 12th sum, there is a square lawn, and only on 3 sides it is bound by a path 4 meters wide. So this time the path is on the outside, not the inside. And the area of that path is 7/8 the area of the lawn. Find the dimensions of the lawn. Well, the lawn is square, so let's assume that the side of the square is x, and that's all we need to find in the end. The diagram is like this. It's a square. Yeah, it looks like a rectangle, but just understand that each side would be equal, x, 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 and x. And this is the path outside. It's a lawn path. Now the width is 4. So here we have 4 and here we have 4. So the outer length of this rectangle will be x plus 8. But the breadth will just be x plus 4 because we have a width out here. We don't have it out here because in the question it is mentioned that it is surrounded only on 3 sides. So for the outer rectangle, the length is x plus 8 and the breadth is x plus 4. So the area of the total outer rectangle comes up to this expression. Now, area of the path is given as 7/8 the area of the lawn, and area of the lawn was actually x squared. It's a square, by the way. And area of the path, according to the diagram, is the shaded portion, which is the big rectangle area minus the square area. So area of the path is the big rectangle area minus the area of the square, which is equal to 7/8 the area of the square as per the question. So that's how you get this equation. You cross multiply, simplify, you get a quadratic equation, and you get two values. One of them is negative, reject that, and finally the side of the square lawn is 16 meters. And finally the 13th sum. the area of a big rectangular room, 300 meters squared. And if the length were decreased by 5 and the breadth was increased by 5, still the area would remain same. Find the length of the room. So we'll use a table method to solve it. So we don't have to write any statements then. This is far easier. Let the original length be x. And the area was given as 300. So what would be the original breadth? 300 upon x, because breadth is equal to area upon length. Now, according to the conditions, the length is decreased by 5 and the breadth is increased by 5, and the new area will be length into breadth, which is this into this. But they have mentioned that the new area is the same as the old area. So this is equal to this. And that's how we get the quadratic equation. Now, before opening the brackets, you may want to do LCM of this, or you may not choose to. Either way, in the end, you get this quadratic equation, splitting the middle term, and you get two values, negative values rejected, and that's how we get the answer as 20 meters for the length. And though they have not asked for the breadth, if they would have, it would be 15 meters. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.